started our startup in 2015, and this is our concept, our company concept. So, benefit. Actually, the BEM means tool in Japanese. So, by the BEM. Yeah, this is a joke. Yeah, actually, we try to create this tool-borne society. So, thank you.
Thank you so much, Dr. Kuda, for sharing the information about the metagen, how we first do the research and then founded these companies. Really appreciate it. Next, we would like to invite Dr. Chong, perhaps to do some self-introduction and perhaps share a bit on your research profile related to gut microbiota. Please, Dr. Chong.
Right. Thank you. So, thank you for inviting me for this forum. So, yeah, you can just call me Chun Lee. So, just a little bit background of myself. I started off as a microbial ecologist, so mainly looking at the soil microbial functioning and also the response to climate change when I was doing my PhD. So there were a lot of fieldwork involved. So after I completed my PhD, I started working in a medical focused university in which I was able to apply my knowledge in terms of molecular microbiology and also bioinformatics. So then I started off working on, sorry, can you move to the next slide? Yeah, thank you. So, so I started on working on the gut microbiome, understanding the relationship with the health and diseases. So I've been working on parasitic infections, the microbiome, the presence of antibiotic-resistant microbes in the gut, and also the some study on Parkinson's disease. I also have a study on looking at diabetes, in which we actually designed a mobile app looking at the responses of the diabetes, sorry, pre-diabetics with the physical activities, the diet, as well as the changes in terms of microbiome. Can you please move on to the next slide? Yeah, right, okay. So just sharing some studies that my group were doing. So the first one, you can see the top panel is actually on the coffee consumption. So you can see the graph on the left, you can see the red line. So that's actually the excretion of caffeine by female. And then the blue line is actually excretion of caffeine by male. So you can see that the female actually excrete caffeine much faster after consumption of coffee. Okay. And in fact, the responses to the microbiome is more long-lasting in female, although they excreted faster. And one interesting finding is that the metabolism of female is actually influenced by the caffeine. So meaning that there is basically a gender difference in terms of responses to caffeine consumption. So I think this is one of the main application of studying microbiome in relationship with food. My group also involved in the study of Parkinson's disease. So we have a small trial looking at how probiotics help in the improvement of quality of life of the Parkinson patients, in which we found that the probiotics are able to reduce constipation, which is a very common symptom among the Parkinson patients. Through the use of LCMS metabolomics and also NMR metabolomics, together with the microbial profiling, we identified the interaction between the different omics. And finally, we also did a small meta-analysis by looking at what are the consistent findings in terms of the microbiome that has been implicated by the different Parkinson study across the world. So finally, I think this is more relevant to Malaysian. So we do have a study on the Malaysian microbiome. So we look at the different factors that could contribute to the differences in the microbiome. So one of the major factors is, not surprisingly, the ethnicity, right? So why ethnicity is so important? Because it actually, the different ethnic group will have different lifestyle and different diets, right? So these are the main contributing factors to shape our microbiome. So you can see the bottom right corner, there's sort of like a very busy map, a busy figure. So you can see the blue dots and the yellow dot. So the blue are actually from India. This is the microbiome of Indian from India. Okay, and then you see the yellow dot, which is on the left hand side. Those are the Chinese from China. So you will see the Malaysian is somewhere in between. So this is interesting because we are made out of a multi-ethnic community. We have Malay, Chinese, and Indian, right? And our food is somewhere in between, right? It's possible that you are eating Chinese food for breakfast, and then Indian food for dinner, right? So you can see that that's how it shapes. But I think one of the interesting findings is that when we group them based on Chinese from China and also Chinese from Malaysian, it's also different, right? So meaning that the ancestry, although may play a role, yeah, but the diet and also lifestyle is actually a stronger factors compared to genetics alone. So these are some of the works that I'm doing. So in all, my work are trying to look at how microbiome contribute to health, and actually the main thing is what define a healthy microbiome. Right. Thank you. That's about me. Thank you.
Thank you. Thank you so much, Chong for sharing the introduction. I think we learned a lot. Some of your findings is actually quite interesting to see how the application of gut microbiota research in different fields. Next, we would like to invite Dr. Tan, perhaps to share about himself, also about Emily. Please, Dr. Tan. Yeah.
Can you hear me now? Thank you, UKM, and the organizer for inviting Emily to share in this platform, and of course the guests for your time, and for us to share our passion, the work that we have been doing, and we are progressively looking for new height. So the topic today under this panel is understanding our gut microbiota. Very glad to be sitting with two very distinguished scientists because they have kind of simplified the understanding of microbiota to make my sharing on how does Emily bring science from lab to industry and to society. So a very simple description of Emily. We are in our 4th years old. We started 2019 in August, and we right straight into COVID. So when that happened, we asked ourselves, what should we be doing? So then it go back to the original. Why do we start Emily? Emily is not the girlfriend of the 4 male co-founder you see in the picture. It actually means the Asian Microbiome Library. So we have, and on the screen, the guy on the left that you are looking at, standing, he is Dr. David Ong. He used to be the head of gastro department in the National University Hospital, National University School, Medicine. He started the first Bio-Teachat transplant. I was a research administrator then, supporting the first trial of FMP trial in Singapore. So as the whole world moved in the growth trajectory in the application of gut microbiome, in this part of the world, we actually kept stagnant. So after 5 years, the 4 brain men decided to come together, put their money together, and started Emily. So with the vision of first, let's just collect enough stool, collect enough data, get the right people, then we figure out what we want to do. So during the last 2 years, the 4 of them has worked very hard with cool academic partners and brilliant scientists, and one of them is Dr. Chong, and they set up a fantastic biobank and database. So we are actually in the execution and application phase. So we created the Emily Prime that store our database and analytics that we are currently building and trying on some of consumer products, or the food for health, where we do food-related validation, because as the 2 scientists I explained, food is the one thing that we can control to have a better gut, better health. So this is a very busy slide, but it more or less summarizes what Emily journey has for the last 3 years and moving on. So as you can see that we spent 3 years finding the right people, and these are part of the team. but they are actively involved in the scientific, technology, and the data's curation, application, and transformation. And with these people, they were always meddling with a set that Emily has. There is one, the biobank, which is our stool bank. We had more than 3,000 stool sample that we used it for academic research, for funding our Emily private research, and of course for commercial services like the food for health that I'm going to share a bit more. And for technology, we created the Emily Prime, which is primarily like a data lake. We store more than 1,000 lifestyle survey, more than 5,000 microbiome data of multi-ethnic group, and in a wide demographic profile. So using the right people, the strong amount of samples and data, we roll out all very unique type of services. So if you see in the 4 purple square, looking at how do we leverage on these 2 collection we have, we started our in-house microbiota transplant product. So it is a very comprehensive step that we seek for donor and transform the fresh stool into the FNT product. So it's a product of 150 ml per bottle that we kept it in our laboratory. So clinicians such as the gastro who are using them to treat a specific gastrointestinal disorder will then order from us. And we will be a supplier with the protocol of hauling them because they are stored in -80 degrees Celsius. And of course, the procedure of instilling through the colonoscopy. There's a yuck factor here. We actually had tried and successfully encapsulated. So we have them in capsule. So you think, okay, not a space for joke, but maybe you will. Yeah, so some of them actually swallow the stool sample. It's not an easy task. It has to be brave enough to go through the psychological effect. Plus, you have to swallow 10 of them, half an hour, the -10 in your head. It's not M&N, so don't worry. Right, so we have our NUS, Gleneagles, a gastro who has actually one of our regular research partner and was somebody we supplied to. We did a study with one of the Gleneagles gastro on studying the patient who had long-term C. diff with a comfort cognitive disorder. We have published that paper. They found that the engraftment started very early as 2 hours post FMT, constantly had good diversity and abundant growth in the next 3 to 6 months. The only thing that when we started this, it was too early for us to recommend any food intervention. So can you imagine for most of your life, there are 2 things that you do most often. One is you control all the diet you have. That means there's no McDonald's, Starbucks, Kueh Lapis, right? It's all very simple food. And everywhere you go, you have to make sure that you have a toilet that you can access within 10 minutes. And after FMT, you not only don't have that problem, you are able to tolerate a wider range of food once you go rampage on your dietary. So we have actually looked at a lot of patients who do post-FMT, and if they continue to design a better diet, the FMT benefit can actually last more than as long as a year. We continue to be working with partners to be writing papers and following up with the patients that has received the FMT treatment. The most recent one, which is in the year past, where we realized that a lot of treatment and application along gut microbiome, rightly illustrated by Dr. Chong, is diet. So as we have so many people looking at doing gut health tests, and the next question is, so what? So Emily does have an in-house probiotic formulation that we have used the data of what is lacking, what are the microbes that's lacking that we can promote or inhibit, and we created our probiotics. But there's still a population of people who, one, cannot swallow tablet or don't like to swallow tablet. So we decided that we should go into the journey of food recommendation. So our first customers that comes to us by serendipity, because we were talking about how to promote gut for their MNC colleagues. I think you have heard about yours. Yeah, yours. Yeah. So we approached them, and it wasn't very keen at that time. But they told us, why don't you start with a small startup? So we went to a vertical farming in Singapore. I think in Singapore, the car park is smaller than anything in the classroom. What more about farming? But we do have the vertical farm. So we visited the vertical farming, and we saw that they grow a lot of kale. One, Asian don't eat a lot of kale. Two, Asian don't eat a lot of salads. But interestingly, their kale is more of a hybrid of Kailan kale. So they have an 8 cm stalk that they cut it away and they threw it away. And you and I understand that the stalk is where all the minerals actually is transported to the leafy of your vegetable. So we took a bold step and say, you know, I have this amount of money that I need for consumable. Will you be able to pay me this amount of money that we'll try to do a prebiotics kale stalk powder? So we took the stalk, which they are supposed to throw away, powder it, seed it into our stew where we had sequenced and we know the microbes that's in this profile of the stew sample. We let it grow for 2 weeks in different permutation of the inoculation. And then we extract it and we sequence it again. So we are able to see the microbes actually happily feeding on the prebiotics rich kale stalk powder. So Lactobacillus the bifido actually grows by 5 times after only 2 days. And when we increase the volume, it actually increased within the next 2 to 3 hours. So we have been talking to the customer sustenance to actually develop. Whenever we drink too much coffee, the next thing we will think of is green tea, right? But they are so high in caffeine, and I'm very sure my scientists will tell it's no good. Have you thought about having a kale tea? So it actually tastes quite interesting, but we will manage to. But can you imagine when you drink tea, you're actually feeding your microbes? So the second customer who heard about what we did came to us. It's no further, but it's Sarawak. So Sarawak is one of the national sago plantation. They are very interested to know why are some of their prolonged sago staple eater so healthy. What is in the sago, or what is in sago that our microbes like it so much that they are healthy, right? Good health start with gut health. And we went all the way to Mocha on a propeller, went to the plantation, observed how they grow the sago tree, it's like a palm oil, how they chop it, process it, mail it in different stages. So they engaged Emily Service, understanding that they do not have the capability or the financial ability to do a human trial, but we at least have a stool sample that can mimic the gut environment of the individual. So we did a similar test. It was quite interesting that a preliminary result was to be shared with them in March. So it's akan datang. Okay, so write to me, I'll share.
Thank you so much, Ben, for sharing on your experience and also regarding the Emily leveraging the gut microbiota. But I believe we love to know more
Yes.
from you, perhaps in the next round. Thank you, Gwen. Really
Thank you.
appreciate it. Okay, ladies and gentlemen. So in the next rounds, we would like to uh, share on the more in understanding the science behind gut microbiota. So just now we had heard from Dr. Fukuda on the technology or platform that being used in studying gut microbiota, which involve metagenomic and metabolomic. But how this data from this platform being used, first being integrated, and how this could be used with regards to understand the human health and wellness. So perhaps Dr. Fukuda could share with us, enlighten us about this, please.
Yeah, actually, our omics technology identify which kind of metabolite they are good for. And also, gut microbiome profile different in very different individuals. So that's why my idea is that firstly we check the your gut microbiome, and then we recommend some good prebiotics for your gut microbiota. That's why, and we recommend some good prebiotics. If your gut microbiota metabolite, then they produce good metabolites. That is, the postbiotics. That's why, this is one of the idea our metabolism approach.
Thank you so much, Dr. Fukuda, for sharing with us here on the technology, how this approach could benefit the understanding human health and wellness. And Dr. Chong, just now during the introduction, you shared some of your research experience related to gut microbiota, in which the correlation of this gut microbiome with the development and progression of several chronic disease, including Parkinson's disease. And you also mentioned how this one of the finding, to be more specific, in the Malaysia demographic, the ethnicity somehow play major roles in the data complex or in the large variation. So perhaps Dr. Chong, Chui, could you share a bit on this with us, Dr. Chong?
Right. Okay. Right. So I think again this is related to the diet which Gwen has touched on. So again, the diet diversity in Malaysia is tremendous. Yeah. So the amount of food or the type of food is very different. Okay. We talk about the lifestyle, and it's actually not only about the food you eat and how you eat. Yeah. So the meal time, the differences in times between your first meal and the second meal will also play a big part into determining the gut microbe that a person will harbor. Okay, the differences in terms of all this will then translate to different responses to diseases. Yeah, so it's usually a very complex interaction between the diet, the physiology, and also the environment. Okay, so in order to fully understand this, one of the main requirement is you need to have a big enough sample size, okay, in order to account for all the different confounders. But I think the challenges in Malaysia is that a majority of our funding scheme will not be able to support this, because this is going to be a top-down huge project. So I guess this is something that I think before the start of this event, we were in the holding room. We were discussing about, for different universities should join, join forces in order to create a big database, big enough in order to understand how the microbiome truly works. Yeah, and also in helping to improve the health of the community. Thank you.
Thank you so much, Dr. John Chui. So next, we'd like to know more from Dr. Gwen Tan, as that she shared just now on the how MLE leveraging this gut microbiota research to provide such a service. So more on them, the MLE had developed on the stools bank. So as we all know, the setting for Singapore is almost similar with Malaysia, with a large multi-ethnic compared to the Japan. So perhaps Dr. Gwen could share a bit on this, how Emily developed in this biostool bank and leveraging it to provide such a service.
Thank you. So the question is, how do we manage to have so many to sample and be able to provide the FMP services?
Yes, Dr.
So we have maybe two modes of. One is to the community, and 2 is with the academia. So we have about 6 to 7 disease plus cohort-related study with most of the university in Singapore and Malaysia, starting another cohort in Brunei, Bumangrat in Bangkok. So these are all shared asset that we will not consider it as something we can commercial. Those that we have use it for the commercial services purpose, either for food for health, our own research and FMT, mainly from the community. So we have a very big initiative. 3 times a year, we go hashtag food save life. So we will be in hawker center, schools, co-working space, public, or we have billboard in bus stop, the MRT station, that we invite donor to donate their stool. So what do? There are 3 criteria that they need to fulfill. 1, they need to pass a medical cell declaration questionnaire, and after which they will have to go through a very simple blood panel investigation, and after which, if those are qualified for 1 and 2, will then go through a very comprehensive stool and blood plus nasal swab. And the success rate is only 1%. So we call this the super poop donor. The second community is where like we have the similar gut health test where you can buy online, and if you are interested to review your gut health, they with a stool sample, post it back to us in the national post. We'll receive. I think Singapore is small, so we can do that. By Malaysia, I think you need courier services. And the second is we have clinical doctors, especially the gastro, who has patient that comes to them with history, prolonged bloatedness or indigestion. And after upscope, downscope, they gave antibiotics and they would like to give some solution. They usually will order the family gut health test because that come with a recommendation of probiotics and food recommendation, food modifications recommendation. So this is how we collect our students.
Thank you so much, Dr. Gwen, for sharing details how the experience in collecting or developing these 2 banks. Ladies and gentlemen, in this 3rd round, we would like to know on how the industry and also the society of this gut microbiota. So perhaps we like to begin with Dr. Gwen again, Dr. Tan. So maybe can you share how such Emily could leveraging this gut microbiota research to develop or to work with partners in developing new or innovative product or maybe service. So perhaps this might be related one of the survey that you've been shared just now during the introduction, Dr. Gwen. Yeah. Okay, a moment. We would like to share a slide from the panel, from Emily.
Thank you. So are you talking about the database and our development?
Yeah.
Okay, so this is one of the questions that has get me thinking of what is the best way, because we have a lot of, we like to build an ecosystem, and coming to here is really very encouraging because we never know who we can find and what we can find. So over the year, we have been looking into a lot of area to gather beside our bio asset, it's also our data asset. So to date, we have been working with academic and our own commercial research, that's our own commercial initiative to bring in all kinds of data. So similar to our bio collection, anything that is a funded research, we won't be using that because it belongs to the university or belongs to the funding agency. So you look at the 2 bubble that is below, it's really the commercial research that Food for Health do a lot of longitudinal study. What do? Leveraging on what Dr. Chong said, we actually had yos who come and invite us to test whether is chrysanthemum tea really anti-inflammation. I think a lot of Chinese will hear that when you are heaty because your lack of sleep, stress, and you eat highly processed food, you will be heaty. Sorry, doctors, I know this is not scientific, but it's very symptom feeling, right? And your grandmother and nanny or mom will say that, please go drink liang teh. Liang teh is usually chrysanthemum tea. So yours want us to see whether is there a way to quantify the qualitative understanding in this liang teh. So they concoct a chrysanthemum tea in their blend. We did a human trial. We make 10 very encouraging individual, range between 21 to 51 years, 52 years old, male and female, diverse of normal weight, overweight, and obese in a BMI, 750 ml of the concoction for 3 weeks. So what we did is we took the gut microbiome before the study, first week, after first week of study, third week, and we also measured the stool calprotectin that's indicator inflammation. And lo and behold, women listen up. So women between the age of 31 to 45, if you are slightly overweight and you eat outside at least 3 times a day, your quality of sleep is less than 4 hours a day, your calprotectin level after 750 ml of special blended Yo's chrysanthemum tea, your calprotectin reduced remarkably after 1 week. And I'm not lying because the analysis, the data scientist sitting next to me. So what we told yours is maybe you should have a product instead of the long, you have a curve. So it's like a shape of a woman. And also the bacteria that is a culprit for obesity actually also very nicely reduced after the second week of 750 ml per day of special concoctions of chrysanthemum tea by Yo. But they are not in the market yet. Right. So these are some of the longitudinal study. My colleagues here, Mr. Lenny Yong is leading a DM diabetes longitudinal studies with the early diabetes with one of the GP groups. So, and commercial, we have a gut health test. If you are interested to do a gut health test, you know where to find me. I'll send you one. But, and we have a sequencing company here, so you don't have to send your suit all the way back to Singapore. You can get a result here. And something very interesting, and we are doing with Raffles Medical Group. If you know about Raffles Medical Hospital in Singapore, they are one of the group practice in Singapore that have both Westerns and Chinese medicine. So in Emily, we had did a very simple study, or rather not simple at all. We profiled the gut microbiome and individual and looking at their traditional body type. So you know, you hear about things called 气虚、痰湿、阴虚, and all this, meaning that your lack of qi, your more qi, you are blend to wetness and all that. And interestingly, some of these traditional body type, which predispose to obesity, diabetes, or cardiovascular diseases, have the same microbes that resonate with the same health indicators. So we brought this to the clinical area, currently working with Raffles Medical Hospital, doing the clinical diagnosis from the Chinese medicine and our gut microbiome. So the whole aim is to create an Eastern meet Western probiotics. So this is where all the data will go to our Emily Prime data lake, where you see in this 2 purple. And Lenny is leading with our CTO in the development of turning all this analytic pipeline, data analytic pipeline, and reference base of our gut microbiome data. And hopefully will work or assist you or support you in designing your health management work or your wellness and preventive health product. For example, your metabolomics can be a very good partner with us because our database is strong and our pipeline are actually quite incredible. And of course, not forgetting, I think you alluded on to the importance of having medical devices that have its own analytic function. Thank you.
Thank you so much, Dr. Quentin, for sharing on the Emily experience. For example, the work with yours. I think that's quite interesting. Perhaps maybe I could share with my wife another interesting finding. Okay, and next we'd like to ask with Dr. Fukuda. I think this is related to the concern from public related to the ethical concern because with the improvement, I think within the conversation of the gut microbiota research and also service provided, perhaps based on the metagen experience. So is there any concerns on this? And if there is, what are the steps being taken by metagen? So perhaps Dr. Fukuda could share on this. Yeah.
Yeah, actually, that is a bit difficult question. So yeah, but in terms of the fecal microbiota transplantation, honestly to say, no guideline. So that's why we are now trying to develop the criteria, which kind of group is good, but nobody knows. Now, yeah, actually in the US and Australia, they have some negative screening system, and also maybe Emily have this negative screening. Actually, that some pathogenic bacteria and the virus and bacteria. But in my feeling, the positive selection is should be required to cure the patient. But actually, nobody knows. But maybe we had some data because then that the microbiome is different individually. But I think the matching should be very important. But yeah, honestly to say that we don't have any criteria. So that's why we are not trying. Yes. Yeah.
Thank you, Dr. Fukuda. So yeah, so on the gut microbiota research, this actually could be expanded to study in animals, for example, to on the improved animal husbandry. So I believe this had been done previously by Dr. Chong on of your previous research. Perhaps could you share more in detail your experience with the study with regards to poultry and what is the prospect with the respective industry, Dr. Chong?
Right, thank you. So I have to be very careful talking about chicken here because we have Singaporean sitting next to me. So anyway, so I have to admit that I don't really have a lot of work in poultry, but I do have a few students who actually works in formerly from UPM. So what we did was that we actually profiled the gastrointestinal tract of a boiler chicken, looking at the different microbiome at different gastro compartments. So the idea is actually to improve the feed. Okay, and then we also have a work on looking into introducing a probiotic strain that have the capability of producing phytase. So phytase is actually an enzyme help in phosphorus absorptions. So yeah, so we have a small trial, and it seems to have quite a good response. And finally, another student of mine was working on using phage therapy to target the pathogens in boiler chicken. So the idea is actually if we can use phage, which is more targeted, then we will be able to reduce the dependence of using the antibiotics. Yeah. So these are some of the work that some of my students are working.
Thank you so much, Dr. Chong Chui, to share some of your works, how this leveraging gut microbiota research not only limited in improving human wellness and health, but also could be in the improving animal husbandry. So for that, we already reached for the fourth round, in which we would like to hear the thoughts from all panelists about the future prospect and also the potential of the gut microbiota research, perhaps through to the collaboration and etc. So here I would like to begin with Dr. Gwen, Dr. Tan. Maybe could you share from your perspective, your point of view, what is the future of the gut microbiota research and conversation? What are the key challenges perhaps you could share with us and the opportunities that lie ahead?
We're just talking over lunch today that our gut microbiome is actually our second liver. So if we are now looking really hard and how is gut microbiome awareness, modification, therapeutic, or even prevention going to be the next era of medicine? Should we start with food? Because that's what we do every day. That is what we are empowered to do. And that's something that is within our ability to do. So, And understanding food will have to take all the food vendor out there, or the ecosystem to come together. So for me, I believe the data is facts. Facts is like you standing on solid ground. So all of us, I think most of our gut microbiome, together with the scientists, has so many data, so many insights. So they are all in our own silo area. And we now pull together and see what insight can we draw, that we can draw a roadmap of food that is not only tasty, but good for you. I think personalization is too far-fetched at this point. But just good to feed on your microbes. I really like the animation where the burgers goes in and then the microbes are feeding on it. So we hope that that burger eventually actually can calculate it's feeding which microbes that is personalized to you. So there is always a reason why somebody is unhealthy, but it's always a personal reason why a person is healthy. So I think that will be something we would like to crack in Food for Health Emily and in our Emily Prime engine. Thank you.
Thank you so much, Dr. Gwen Tan. I think I learned a lot. We all learn a lot from your thought, how you share on the vision from the food and how which microbe that actually will digest the food and everything. So next, perhaps we would like to know from Dr. Chong your thought. Maybe could you share in terms of collaborations, the model, what actually the role that could be played between by academia or industry, and how to drive this forward towards the true conversation of the gut microbiota research.
Right, thank you. I think this is a hard question, but anyway, so I think different partners will have different role to play. Like for example, the academia would be able to provide the technical expertise, maybe access to the facilities in the university, whereby the industry will be able to provide funding, networking, and also the initial idea for research. Whereas finally, for maybe the government agency will be able to provide incentive policy that promote this type of collaborations. So through the private-public partnerships, so normally what will happen is something like eDana, whereby the government provide the funding, and then we will have to make the industry together with the university to work together, and the funding is supported by the government. So I think that's one model. Another model would be perhaps like what Emily is doing. So Emily will approach the academics in order to speed out the development of the product so that it can be rolled out to the market faster. So I guess these are some of the models that we can work on, and it has already been a proven model. It's not something that I thought of like just sitting here, but yeah. So I think the trick is how do we promote this further? Yeah. Thank you.
Thank you, Dr. Chong Chui, for sharing your thought on possible partnership model. So next, we'd like to know from Dr. Fukuda your thought. Maybe can you share the prospect of gut microbiota research and conversation from metagen perspective? So could you share what actually you would like to explore? Is there any potential collaboration within not only in Malaysia setting, but perhaps in Southeast Asia? We would like to collaborate with local academia or industry or partners, not in gut microbiota field, but perhaps in other fields as well. Yeah.
Thank you. Yeah, actually, our vision, our company vision is to create a disease zero world. So yeah, gut microbiome is highly power to modulate our homeostasis. So that's why in Japan, and now we are now developing a new service in Japan, and my aim is the reason why I am here is that I want to expand our business in Malaysia. But yeah, we don't have the collaborator now, so that's why in this seminar, many food and supplement company and also a sequencing company like that. So that is like if you are okay, maybe we want to collaborate with all of them because we want to start this very important the gut microbiome service and gut microbiome research because science and business, both of them should be required to expand the importance of gut microbiome in the world.
Thank you so much, Dr. Fukuda, for sharing your thought. Ladies and gentlemen, I'm sorry that we are actually running out of time, but we do hope throughout this discussion, so perhaps we could have more insights on the gut microbiota research from different perspectives, whether it's from the laboratory settings or in the towards conversation from industrial perspective, the service could be offered. And I do know perhaps there is a question from audience. Perhaps I could only accommodate maybe one question. If there is a question from our audience that would like to ask to these high esteemed panelists that we have here. Yeah. Okay. I believe perhaps if you ladies and gentlemen have a few questions, so you feel free to connect with all these panelists. So on behalf of the VNS, first we would like to thank you to all panelists, Dr. Shinji Fukuda, Dr. Chong Chui, and also Dr. Gwendolyn Tan for your time to join us as a panelist and to share all your experience on top. Ladies and gentlemen, please let us give a round of applause to the panelists. To that, now we already conclude for the forum session 1. So now we would like to move to the second forum session, in which we would like to invite the moderator of the session, Mr. Ayapa, to moderate the session. Thank you.
Okay, all right. Thank you very much, Arif-san. Okay, everyone. It's nice to meet you all, and very good afternoon to everybody. Sure, many of you are feeling a little bit tired, but let's move on to the next forum discussion, and let's try to make it more engaging and more interactive with all the members of the audience. Okay, so for this forum discussion, we'll be having on the topic, which is corrective and preventive actions in gut health. And our esteemed panel members will be Dr. Edward Chan. Could you join me here? So Dr. Edward Chan is the lab director and principal consultant and nutritional therapist for Well Lab. Next, we have also Dr. Deborah Chia. She is a gastroenterology and hepatology consultant at the Department of Medicine, UKM. And finally, we also have Mr. Chin Kok Kian. He's the managing director of My Miracle. Okay, thank you. Thank you for joining me. All right. So this session is more, or we are going to be talking more on the corrective and the prevention actions in gut health, as well as exploring different solutions to be implemented and to address gut health problems. And we are also, here we have actually experts from a diverse background. We have actually Dr. Edward. He has expertise and specialized in psychology, and you can actually interact with him and try to understand how exactly psychology is correlated to gut health. And as well as Dr. Deborah can share her input on the vast knowledge and also her experience in this field over the years, and also the studies that she has done. And then we have Mr. Chin to actually provide us more on a business perspective on how exactly these probiotics or something to do with gut health can actually help with the society. Because Mr. Chin actually has something that I've never heard of before. Maybe I will address that later in our forum session. Okay, so before we move on any further, let us have each of the panelists to introduce themselves. Maybe we'll begin with Dr. Edward.
Hi, good afternoon, everyone. Yes, I'm both a psychologist and also the nutritional therapist, and I occupy this intersection between gut and brain. I heard just now from the panelists, someone mentioned about the gut is like the second brain. Yes, there's a lot of truth in that, but specifically, I'm going to talk about some lab tests that we can actually measure provided by Well Lab, right? So I heard a lot of talk about gut dysbiosis. So in Well Lab, we will actually be providing some lab tests on the gut health, like leaky gut. Some of you might have heard of that, and how leaky gut is causing autism, depression, schizophrenia. It's all related from leak in the gut, and I'll go into some specific details on that later, and about other things. Back to you.
Yes, thank you very much, Dr. Edward. And then now let's move on to Dr. Deborah. Maybe you can introduce yourself.
Hi, good afternoon. My name is Deborah. I am a consultant gastroenterologist and hepatologist in a university, National University Malaysia Medical Center. And my main interest is in pancreaticobiliary diseases. And there has been a lot of interest in the gut microbiome lately. And in fact, in 2022, at the end of the year, there was a paper published that in patients with pancreatic ductal adenocarcinoma, there is a change in the signature of their gut microbiome. And this early change can actually predict the occurrence of pancreatic cancer. And it can also be used as a potential biomarker for pancreatic cancer. So my other diverse interests in gut health include irritable bowel syndrome, as Dr. Edward alluded to. It is termed as leaky gut syndrome, in which we see that in patients with irritable bowel syndrome, there is gut dysbiosis, and this predisposes them to low-grade inflammation, which results in a gut-brain axis dysfunction. So my other interest also is on gut microbiome and chronic liver diseases, as we can see there is a diverse dysbiosis that occurs from chronic illnesses such as hepatitis B, hepatitis C, and NAFLD to cirrhosis, and even finally liver cancer. So I'm sure we'll be able to discuss all this in further detail, as well as the preventative measures that we can do, which encompasses lifestyle modifications, low FODMAP diet, and even a Mediterranean diet and probiotic supplementation that we can use to augment the gut microbiome in order to return it to its healthy state.
Thank you very much, Doctor. All right, and finally, let's have the introduction from Mr. Chin.
Hi, everyone. A bit nervous because all are doctors. I'm agriculture background. Been in business for last 30 years. Initially in polymer business. So the polymer business is there. Then from polymer to farm nutrient, tocotrienol, MCT, C8, and to coconut. Then during this MCO, we acquired 2 patents to produce postbiotic from UPM. The research have been done last 20 years and still ongoing by Prof. Wu and Prof. Loh. So it's very new. We term it at 5G biotic after probiotic, antibiotic, prebiotic, parabiotic, and postbiotic. The only difference with postbiotic is there's no live cell inside, just metabolites. And we have last 18 years during the MCO, we acquired a patent last year. We have put out a bioreactor and a GMP plant. We have halal, GMP, HACCP, and also we just got registered with MAL and PRA. We also get our BioNexus status, where we are exempted for 10 years tax for in last 18 months. So we are a new startup actually. Okay, thank you.
All right, thank you very much, Mr. Chin. Okay, so let's just get into the discussion. At the same time, I would like to recommend that any of the audience members, if you have any questions during the discussion, you can actually lift up your hand and I will address you, okay? So that we can make this a little bit more interactive, okay? All right, now, so let's get right into it. Dr. Deborah, maybe we would like to have a little bit more explanation on how exactly does gut health affect our overall health? Maybe you can share on that.
Certainly, I'll be delighted to. So there's a lot of talk on gut microbiome, and in fact, it's shaped from birth. We see a study that was done on babies who were born via normal vaginal delivery versus cesarean section, and we see that even the mode of delivery affects the diversity of the gut microbiome, because patients who are born via cesarean section lack a biodiversity, and this has been shown in later life to predispose them to diseases like inflammatory bowel disease because of the lack of the biodiversity, where when the baby is born via the vaginal canal, the vaginal flora that actually is in that area actually goes into the baby's mouth and it colonizes their gut, and it results in a more diverse gut microbiome compared to babies that are born via C-section. And as a person ages, certain things like diet, their weight, their health status, whether or not they have diabetes, whether or not they have impaired fasting glucose, these sort of things influence the gut microbiome, as we see patients who are overweight have a higher proportion of short-chain fatty acid producing gut microbiome, which is actually unhealthy and predisposes them to the formation of non-alcoholic fatty liver disease. And as we see across the spectrum as well in diseases such as chronic liver disease, which encompass hepatitis B, hepatitis C, and fatty liver, we see that the gut microbiome is altered, where we see that due to the increased permeability of the gut, the antigens from outside, from the gut actually migrate into the blood, and this results in low-grade inflammation. And it is a bidirectional relationship where this low-grade inflammation is also perpetuated by gut dysbiosis, because the danger-associated molecular pathogens and the pathogenic associated molecular pathogens predominate in the gut, and it gives them a gut signature which is inflammatory in nature, and this predisposes them to the formation of hepatocellular carcinoma, also known as liver cancer. So talking about other diseases such as irritable bowel syndrome, a lot of patients we see in the last decade have been presenting with very non-specific symptoms like abdominal bloating, altered bowel habits of either constipation or diarrhea or even both. And we find that when we do scopes on these patients, they have a completely normal scope finding. And when we biopsy them, there is an absence of any form of microscopic colitis. But when we sequence their gut microbiome, we find that they have what we call gut dysbiosis. And this is termed an impaired gut-brain interaction. And because of this gut dysbiosis, there is a decrease in bifidobacteria, and there is an increase in Lachnospirae and Akkermansia, and these are actually termed as the bad gut bacteria. And this results in an inflammatory picture in the gut where the inflammation is very microscopic. It cannot even be seen on a microscopic level, but it results in increased sensitivity of these patients to complex carbohydrates, and it results in pain as well that these patients commonly complain of. And this can be exacerbated by stress, where we find that patients frequently report that stressful events trigger diarrhea or constipation and also trigger pain. So one of the studies that we did in collaboration with UMMC was actually a study on whether the low FODMAP diet, which is an elimination of complex carbohydrates, could actually correct the gut dysbiosis. And we found that actually in patients who have irritable bowel syndrome and are on this low FODMAP diet, there was a corrective measure seen on the gut dysbiosis, where the gut microbiome actually returned to normal. And also this had an impact on patient quality of life, where they reported less bloating, less abdominal pain, as well as less symptoms of diarrhea and constipation. So another adjunct of our treatment also is very low dose antidepressants, because we have also shown that depression and stressful life events and even anxiety or coping disorders can impact the gut microbiome adversely. So the last thing that I would like to talk about that has gained recent interest in the last 5 years is non-alcoholic fatty liver disease. So, with the Malaysian diet that is very rich in carbohydrates and fat, the occurrence of obesity has increased in the last decade. And when we look at the epidemiology of liver cancer, we see that 20 years ago, 48% of patients with liver cancer were attributed to chronic hepatitis B. And in the current last year, which was November 2022, we published a recent paper that showed that the epidemiology of liver cancer has actually changed. And 47% of patients with liver cancer actually have fatty liver as an underlying cause of their liver cirrhosis. Now, this also adversely affects the gut microbiome because in patients who have fatty liver, they often have the coexistence of impaired fasting blood sugars as well as diabetes. And this results in the increased production of short-chain fatty acid producing gut bacteria, which is harmful to the gut because this also predisposes patients to what we call leaky gut, resulting in an increased permeability of the gut to food antigens. And this can also be used as a signature marker for the predisposition towards cirrhosis as well as non-alcoholic steatohepatitis. So we found that implementations of corrective measures such as hypocaloric diet, Mediterranean diet, and even supplementation with probiotics. And I have to state that the FDA definition of probiotics is a compound that has certified live or beneficial live organisms, and they usually are bifidobacterium. So we found that the lifestyle measures as well as administration of probiotics were able to correct the gut dysbiosis in these patients. But again, to bring it back to normal was a bit hard because of the underlying liver disease. So I think in summary, to summarize, the gut health has a lot to do with the overall well-being of a patient. And there are many instances where gut dysbiosis or alterations in the gut microbiome predispose patients not just to gastrointestinal disease, but also other diseases like Alzheimer's, and even it's been shown that gut dysbiosis can result in dementia as well. So as a result, we need to pay attention closely to our gut flora, and in conditions that can predispose to gut dysbiosis, corrective measures such as lifestyle modification and even the consideration of probiotic supplementation can be implemented in order to correct the gut dysbiosis.
Wow, that's a lot of information to process at one time. But yes, I think that's what exactly it is to talk about gut health in overall. So to address what Dr. Deborah has mentioned in terms of high cholesterol and high sugar diet, right? And in how it actually impacts our gut health negatively. So probably, Dr. Edward, would you like to add on to that? Because I believe that your at Well Lab, you actually run certain tests in order to see the correlation between gut health as well as the between high cholesterol and high fat diet, high sugar diet.
Sure. Would you want to share some of our slides for that, right? Okay, so all right, so these are the gut tests we will have at Well Lab, right? So the leaky gut is called the intestinal permeability, right? So why is it intestinal permeability? Because there is a protective layer in our guts, right? What we call the blood-brain barrier, whereby toxins is kept out and nutrients are absorbed, right? So we can actually test that in Well Lab. This is a functional test by which we will give patients, it can be a child or adult, certain liquid to take mannitol and lactulose, which are relatively large, in terms of molecule size, that consume this, and after that we will collect 6 hours of urine, and then you can see, right, from the results whether there's like in the reference range too much either of this molecule being collected, then we will then be able to confirm there's a leak, right? Compromise intestinal permeability, or even a malabsorption whereby not enough get through. So either way that needs treating. right? So this would be suggestive of gut dysbiosis. We also have a stool test directly. So this is more than functional test where we can look at various analytes. So we can look at, for example, short chain fatty acids. If it's too much, right? These are produced by so-called bad bacteria, opportunistic and bad bacteria. When you have too much sugar, we were talking about, too much indigestion. We have other tests that they look at food allergy, food intolerance. For example, if you have that, then that might lead to an overgrowth of all these opportunistic and bad bacteria, which would change your gut microbiome, right? So then you might get a high short chain fatty acid. On the other hand, we can also look at an enzyme, pancreatic elastase, right? Whether that is sufficient or not. If it's insufficient, that again would be related to just now we're talking about diabetes, right? Even pancreatic tumor, cysts, then we can do further investigation. We have other tests to look at that. And we'll also have a long chain fatty acids, right? So these if it is elevated, then it might indicate inadequate lipid absorption. So this might be like good fats, omega-3, omega-6. We also have another test that look at the ratio between omega-3 and 6, which lead to a lot of psychological disorders like dyslexia, for example, right? Here, this is another page of the same test, right? So these are all the different analytes, metabolic markers of very essential elements like butyrates, acetates, all right? We have a specific ratio of these, valerate, right? So if these are not adequate, right, decreased level, it might indicate inadequate colonic function, right? Gut dysbiosis, and we might need to go back to prebiotic, probiotic, and we will be hearing about postbiotic even later to rectify that, right? So we can also identify specific microorganism like the yeast, candida, right? Which are pretty harmful, which will cause the leaky gut, right? Parasites, to worms, and the test will also identify treatment, right? Specific antibiotic treatment if you want, or natural inhibitors, right? And we will tell you like carboxylic acid here is 100% effective, right? So you might not need to use antibiotic to kill all your a lot of your beneficial bacteria as well, right? So there are all these benefits. So the next test we do is a complete microbiome mapping, right? So we would look at some of these analytes here, like zonulin, for example, right? It again is a very large molecule, and we shouldn't be expecting much of it. So when we see this is high, so already indicated some gut permeability, increased gut permeability, leaky gut is already taking place. So this is not a functional test, and unlike the test just now, this is a direct assessment of your gut, right? Also your immune system, nowadays you probably heard of gluten-free diet. Some people are sensitive to gluten, and this anti-gliadin IgA would directly tell you if that is the case, for example, right? So we have the complete mapping of all the important bacteria, right? Whether it is enough, not enough, what more need to be done, yeast, fungi, different type of candida, everything is there completely, right? Viral, what are normal, what are friendly, right? The proportion. And Another test we will have, because we have been hearing about diabetes, cholesterol. Actually, not all cholesterol are bad. In fact, cholesterol are very beneficial. We need cholesterol to make hormones, and I think we might be hearing about stress as well, right? Hormones and something called neurotransmitters, which are brain chemicals. For example, if you're depressed, you won't have enough serotonin. You may not have enough dopamine, right? And that is from cholesterol. So our lab are the only lab in Malaysia that provide you a differentiated measurement of your cholesterol. Normally we think LDL is bad cholesterol, but no, it depends on the size, how dense it is, right? So here we can see it is the LDL 3, 4, 5, 6, right? That are especially atherogenic, right? That will cause heart disease, and it also cause dementia. Now we have research data to suggest high correlation, right, of all these LDL subtractions to dementia, for example. And it is linked, of course, to the heart issues and gut issues. So I just need to bring to your attention, and also the oxidized LDL, whether it's oxidized or not. And again, it goes back to diet, right? So why do we get oxidized oxidized LDL? Because of the oil we use, right? Like the very harmful vegetable oil that is easily oxidized, very low smoking temperature, right? That's so I always bring my own oil to any restaurant, right? Either you use my oil or not going to eat that, right? I decide, so I bring my own grapeseed oil, which has a very high smoking temperature. It's not going to be easily oxidized. Or I bring my coconut oil, right? That will never get oxidized because it has no omega, no long chain poly, etc., the fatty acid, right? So yeah, if you want to have good mental health, do that. Health, do that, right? So on the other hand, if you are worried about your cholesterol, do this test. Don't just rely on your typical cholesterol profile. Okay, I think okay. So talking about stress is not all bad, right? It's we need stress, certain amount of it. In the morning, we need cortisol, right? The stress hormone to wake up, right? So for those of you who feel very groggy in the morning, it's not enough cortisol, right? So we have a saliva test. So other lab will do a blood test, right? Which will stress you out. So it's not accurate because when you get tears on the needle, you have increased stress. So here, our lab offer you a very non-invasive saliva test, right? We in fact give you 6 tubes to collect your own saliva at home, right? So we want to see the chart, the profile throughout the day, right? So for example, the first 1.5 hours is where your engine starts, right? You can see that. If it's too low, your engine is not starting properly, the rest of your day is not going to be working properly, right? So we measure your cortisol level throughout the day at specific points. And then we also measure your DHEA, which is your anti-stress hormone, and see whether there's a good balance or not, right? And depending on how it is, then there are various treatments, right? I mean, you can use medication like cortisone to boost up your cortisol, but there are also natural supplements like licorice root that will do that. Our lab can prescribe DHEA directly to help repair the adrenal gland. If it's compromised, too much stress, then you will stop producing anything. So cortisol or DHEA eventually burnout. You need an overhaul, and it will take a longer time. So do this before it happens, right? And lastly, your brain chemicals that I mentioned, your neurotransmitters, serotonin, dopamine, we measure everything. Not only we measure that, we also measure the drums the downstream and the precursor. So if you don't have enough dopamine, right, you have ADD, you have depression. ADD stands for attention deficit disorder. Okay, so why don't you have enough dopamine? It could be because of the precursor, L-DOPA is not enough, we measure that. Or because DOPAC, which is the downstream metabolite, is too much. That means you're using the metaphor of a bathtub, right? Your bathtub hole is too large for the dopamine flow out, right? So you might have an enzyme called POM, which is the enzyme to break down your dopamine. It might be upregulated. You have the unfortunate, genetic dyes of an upregulated POM, right? This is easily fixed. We can give you some natural herbs like theanine from green tea to slow it down, right? So there are solutions on all these to help, but first of all, we need to identify what is what so that we can address it, right? So this lot of data here, don't worry about it. Yeah, so these are some of the literature, gut psychology. It has a whole host of diets there, and also I'm licensed by Professor Dr. Daniel Ammon, one of the award-winning psychiatrists in the US, right? Looking at ADD, depression, how it's linked to neurotransmitters, gut. Yeah, so contact us.
Yeah, I think if you have you like to do the test, in detail, you can actually contact with Dr. Edward. Yep, thank you very much, Doctor, on this very detailed profiling of what exactly goes on in our body, as well as how it directly correlates with our gut health. Then to actually address what exactly both Dr. Edward and Dr. Deborah were speaking about on the probiotics, prebiotics, symbiotics, all this. At the same time, I'm not sure whether any of you would have been familiar to postbiotics, because I wasn't until I actually met Mr. Chin. So, Mr. Chin, to address more on this postbiotics, could you share with us what exactly is postbiotics and how exactly is it different from symbiotics? How is it different from that? Yep. Yep, sure.
I'm happy just now, Doctor, I was saying coconut oil because we produce coconut oil, coconut milk, and it is easier for us to sell in Europe and US. We don't even bother to sell. Okay, so let's. Initially, Prof. Low and Prof. Fu, especially Prof. Low, is the Dean of the Agriculture, the faculty now in UPM. We are doing a lot of experiment, especially if you go Google Scholars. I think there's 40 or up to 100 study have been published in the high impact journal lately, last few years. We try to find something that can increase the good bacteria in the gut and reduce or suppress the bad bacteria. So what they did is, especially they start with broiler, layer, piglet, swine, especially the piglet diarrhea problem. We see that is after 14 days to 21 days, the diarrhea reduced a lot compared to antibiotic or vitamin C and etc. and probiotic. So we actually gave to some IBD patient, and we find that this is worked very well so far. This is testimonial. There's no clinical trial. All are the animal trial. So then we also want to find that is something that we do not need colonization, because taking outside probiotic to the body, because As we know, we have 30 over trillion bacteria in our gut system. Probably there's good bacteria and bad bacteria. So if taking some foreign bacteria inside, so there's competition, there's colonization before it gave it back. So we actually initially we want to avoid this. Then live cell also, there is a concern for immune compromised group like children and old age people. So these are the path that we come to postbiotic. Also, we want to avoid these horizontal virulence genes transfer, where they can acquire the pathogen genes, and also the very serious the AMR problem. Then also we find through our tests, we measure a lot beside the reduction of cholesterol. We test the IgA, IgG, and IgM before taking the postbiotic for layer under stress, boiler under stress, the sow, especially after lactation, and the rats as well, and also human. We ask everyone who before consume test, beside their lipids, they do trial, do some markers, IgA, IgG, and IgM. And after 6 weeks or 3 months, they go and test again, see how is the inflammation. And we have a lot of good testimonial before I acquired the patent actually. So that is what we do. And another thing is this postbiotic, because it's without any live cell, we can keep longer shelf life, up to 2 years. And when we add into like yogurt, in Japan, now I think around 38 to 40% of the beverage, for example, in 2019, there's almost 300 products from food and beverage is based on whether parabiotic and also postbiotic, because this also can avoid food wastage. Because if you use live bacteria, probably you can store 1 month, but with this without cell, we can store 6 to 9 months. So that's how we come to this. And the very important thing, another very important thing is all the LAB are extracted or isolated from Malaysia local food. The reason being is we know many of the good bacteria or the LAB are isolated from feces, from torrential, from plant, from animal. And nowadays, some country, there's many regulation. They need to know where the LAB come from. And if the LAB come from feces, which I think if you Google, 40% of them come from, or 50% from najis. So it's very hard to get halal, definitely, and kosher for juice. So right from the beginning, we extracted 200 over gram-positive LAB or L. pantaro. And after these 20 years, because some of them can give some benefit metabolite, some of them not. Some of them give it fast, some of them not. So after these 20 years, we already optimized the production. We give the correct food. These are the strains that we isolated. We only left 6 from tempeh, tapai pulut, tapai ubi, ikan rebus. These are the names. So the soluble bioactive metabolites we use in our experiment. So we isolate, we culture them, we fermentize, and we do in vitro and animal trial. So that is what we do at the moment. This is the 2 professors. These you can Google Lotus online. You can see the publication done. We have they have published more than this is around 3 years ago. Now probably more. We have more data. This is semester in, semester out. We do the student, the master student will do postbiotic against antibiotic drug, and we can see the LAB in the gut system. But the bad bacteria actually reduce using this, and we also trial on the every semester. Some student there is some credit on doing this as well. Every day, I think around 100 chicken will be slaughtered in a semester. So we'll test the IgA, IgG, and IgM last 20 years. This is the testimony where the inflammation after taking 6 weeks reduced. This is very common. We have done this. And also the very important in the postbiotic, there is antioxidant activity. So every batch we measure the HRS, the hydroxy radical scavenging, and also the reducing power. UPM also bought some cancer cell and do six cancer cell and trial with all our postbiotic, and we found there's 2, especially for the breast cancer. We are now applying for clinical trial for this for one of our strain, this has written several countries. We did a lot IBS for rats, piglet, sow, broiler. That's what we now doing. My maker, we are doing this. Sorry, these are the 2 patents. So the patent one is for nutraceutical product, which is registered in Malaysia. And the second is the human cytotoxic agent and metadel that are registered in the country. These are the 2 patents that we acquired.
All right, thank you very much, Mr. Chin. I think I can see a very common ground here is that how exactly post prebiotics, probiotics are all at the end of the day, since it affects the gut health, at the same time it also affects cancer. Probably, Dr. Deborah, would you like to elaborate more on what you were mentioning earlier on pancreatic cancer, and then probably we can get also Dr. Edwards' input on how exactly from his studies there is something to do with how it actually affects cancer and how we can actually do preventive measures for that. Yeah, Dr. Deborah.
Definitely, I think that's a very good question. So there was a paper published last year in Gut where a European group actually looked at the gut microbiome of patients with pancreatic cancer and compared that to a normal population. They did age matched, sex matched, as well as disease matched. And they found that the patients who had pancreatic cancer had a significantly altered gut microbiome. And when they looked at the predisposing factors, they found a few common threads. The first is that patients who were consuming high sugar diets, high carbohydrate diets, had a higher level of insulin in their body. And we know now that a high level of blood sugar actually confers an inflammatory state of the body, which is why patients with diabetes are predisposed to malignancies, especially pancreatic cancer. And they found that the level of insulin in the body as well correlated to inflammatory state, where higher levels of insulin indicated that the pancreas was under more stress, and therefore a high sugar, high carbohydrate diet in the long run could predispose patients to pancreatic cancer. But however, the relationship isn't linear. There are many confounding factors such as the patient's body weight, their BMI, with higher BMIs above normal conferring a greater risk, the presence of impaired fasting glucose with a higher glucose level conferring an increased risk, the waist to hip ratio with abdominal obesity also conferring a greater risk because of the lipid peroxidation in the abdomen, which can predispose patients not just to fatty liver, but also to other diseases like arteriosclerotic and cardiovascular disease. And because of that, they found that it was not a simple answer of is there a certain kind of lifestyle or diet that can predispose these patients to pancreatic cancer, but they found that it was a combination of a lot of things, such as unhealthy lifestyle, being overweight, having an increased waist to hip ratio, as well as the presence of diabetes. And another thing was also smoking and alcohol consumption, where they found that smoking in a prolonged duration actually resulted in increased levels of free radicals and a pro-oxidant state in the body. As such, it also conferred to gut dysbiosis, and in the long term, pancreatic cancer could be predisposed in these people. Other than that, also patients with chronic pancreatitis, which is a chronic inflammation of the pancreas and loss of the endocrine and exocrine function of the pancreas because of pancreatic fibrosis, also predisposed patients to the development of pancreatic cancer, and chronic pancreatitis itself predisposed patients to gut dysbiosis, and this worsened once pancreatic cancer developed. So I think the answer is there's no hard and fast rule. Like when we talk about probiotics as well, there's only one treatment approved by FDA for inflammatory bowel disease, and that is BSL-3, and it's only approved in a condition called pouchitis, which is where a patient who's got ulcerative colitis gets their gut removed and gets a pouch reconstructed. And if there is chronic inflammation, BSL-3 was shown to be beneficial in these patients. Other studies on probiotics, again, in irritable bowel syndrome, there was no signature company that could come up with a concoction that improved or cured IBS, but certainly with the supplementation of bifidobacterium, they found that there was an improvement in the gut dysbiosis, and there was improvement in symptoms of diarrhea and bloating in these patients. Hence, it is likely to be beneficial in patients with irritable bowel syndrome with predominantly bloating as well as diarrhea, because it actually improves the dysbiosis in the gut that predisposes them to diarrhea. And in terms of a non-alcoholic fatty liver disease, we saw that the increased levels of blood sugar again predisposed patients to short-chain fatty acid producing gut microbiome. And in the last few years, this has actually been a therapeutic target, where just instead of monitoring weight loss and the BMI and the waist to hip ratio, there has been a shift towards monitoring gut microbiome as well, in the efforts to see whether an alteration to a normal gut microbiome could actually predict a reduced risk of developing cirrhosis and liver cancer in these patients. So the jury is still out there, so stay tuned.
All right. So what about from you, Dr. Edward? Is there anything that people could do as a preventive measure, maybe from the studies that you have gone through, how exactly these results can actually be of like a benchmark for them to look into, oh, I should do something in order to get away from this? Yeah.
So with regards to cancer, we have on oncology, a series of oncology tests. You can go to our Well Lab website to look at that. These are very advanced, very early cancer detection, which are not available in Malaysia, in other labs, but they are already accepted by oncologists in Australia and other parts of Europe and United States. I don't have a slide there to show, unless you can get to the website, you can show our website. But for example, we have a test to look at circulating tumor cells, right? CTC, right? These are actually FDA approved tests, right? So all of us here in this room, we have CTC, right? So the question is whether it is above a certain reference range or not, right? So many of us, we have a good immune system to deal with this CTC to prevent it from escalating. And it also depends on, so our lab test would have a test called on-call count, right? So this is a simple blood test to measure your number of CTC, and we have a reference range on different organ from your colon to your breast to other parts of your organ to see what is the reference range, whether it's above the range or not. So if it's above the range, you might not even have any tumor yet, but for sure tumor will be on the way. So you can take a very early preventative measure, maybe improve your gut microbiome, right? To do that. We have another test called on-call trace, right? So on-call trace is not only looking at the number of CTC, but also on the genetic expression. Right, so there are many patients that they have cancer, right, and they do some chemo, they do surgery, and then they're good for a number of years, and then the cancer come back very aggressively. Why? Anyone know why? Okay, don't expect you to know, but it's because your cancer stem cells is still positive, right? It's still positive. That means you haven't cut the heart, the head of the cancer. Right, you're just dealing with the symptom, right? So our tests have the ability to measure the genetic expression of the cancer, right? So we have different analytes on that, right? So from the ability to metastasize the cancer to the ability to be very aggressive and whether it's a blood cancer or non-blood cancer, all these can be measured, so that if you see the number of expression are positive, then you can also take the preventative measure to turn them into negative, right? Only when all your genetic cancer expression are negative can you say you are truly on remission. Otherwise, it's just a false sense of confidence. Right, so that is the additional thing we can add, right? Our lab also not only enable you to test for the markers, but it also offer treatment, right? So we have give you a choice of drugs, chemotherapy. There are like over 200, you can choose from to measure against your CTC, and we'll give you a report to see, from how, like just now you saw on the gut test, what is the percentage of effectiveness it is, right, to your specific CTC. We do it in the lab, on vitro and see the effectiveness. For those of you who wish to have medical treatment, but for those, we have many patients who wish to have more natural treatment, then we also have the natural substance, right? From ginger to turmeric to, all the stuff you were talking about. And we test it in the lab to see how effective these are, right? Then you will know. So in other words, we have very customized treatment for patient, right? Rather than shooting in the dark and because we know from literature, less than 5% of chemotherapy work. Right, but we can give you very precisely, the percentage which chemo is best for you. It might not be covered by your insurance, right? But then it's life and death. You might want to, right? Well, I would suggest you buy an insurance that do not force you to choose a chemo, right? Anyway, so there are treatment options. We have also something called SOT, which is very effective against cancer, right? But back to you.
Okay, thank you very much, Dr. From the way I see it, the panelists, the panel members we have here, they all have their own expertise. Someone who's more manufacturing, the other person who has analysis and more to targeted therapy, and finally we have Dr. Deborah who assists in clinical studies and then come up with all these real-world results, right? So I think probably after this, the panel members could look into collaborating together on a project and probably a study that can benefit the society or the community later on. Okay, so since we actually are lack of time and we're going to move on to the break as well as the poster session later on, maybe just to end this forum session, could we have a take-home message that let's start with Mr. Chin. Do you have any take-home message for the audience?
For us, every customer that we engage, the first thing, whether they have psoriasis, eczema, or whatsoever, I think the first thing is to ask them to go and do a blood test for what they are allergen to. I think because whatever you take, it may come back. It may come back. Even our gynae say, who use our thing, we want to know what you're allergen to, and what trigger you must eliminate from your diet, and then you improve your gut microbiome. Then I think you can solve the things. But beside that, the sleep, exercise, mindfulness is also important for the gut health. Yeah. Thank you.
Okay, Dr. Deborah?
Thanks very much. So I think my take-home message would be that gut health is very important, and it encompasses not just the gastrointestinal system, but an unhealthy gut and gut dysbiosis can affect organs outside the gut, such as the brain and also the cardiovascular dysfunction. It can result in neurodegenerative diseases and such. Hence, it is very important to adopt a healthy lifestyle in addition to a healthy diet in order to ensure that your gut is in the optimum state of health.
Very short and concise. All right, and finally, Dr. Edward.
Well, I agree with all that is said by my colleagues. But my take-home message is everything can be measured, right? And look at what is your concern. Get that measure, and then you have a roadmap on prevention as well as treatment, right? From your leaky gut situation, to your microbiome, to cancer, to your cholesterol suppressions. Everything can be measured. So measure it, and then you would have a roadmap to prevention and treatment. Back to you.
Yeah. Thank you very much, my dear panelists. Okay, so with that, we end our second forum session. I hope that all of you are able to gain very useful insights, and possibly you may want to seek out these panel members later in order to discuss further on how you would like to maybe probably have a test from Well Lab, and then maybe you would like to look into having postbiotics from Mr. Chin, My Miracle, and then probably you might also want to speak to Dr. Deborah on how exactly, if you are doing a clinical study, how you want to go further with that, and how you want to look into another study, and how exactly gut microbiome is going to benefit our health overall. So, yep, with that, I would like to implore ladies and gentlemen to take all your probiotics, your postbiotics, your prebiotics, okay, and maintain a good gut health. All right, over to you, back to Arif.
Thank you so much, Ayapasan, for the moderation. Also, thank you. Let's give a round of applause to all the high esteemed panelists for the great discussion. Ladies and gentlemen, so now is for the short break in which we will continue with the third session, which will be hybrid. So the session will be start at 5. So ladies and gentlemen, you are all invited for the refreshment, and then we'll continue at 5. Thank you.
Oh, sorry.
Yes.
Thank you very much.
start the session in 1 minute. Thank you. Thirsty. Dear ladies and gentlemen, welcome back to this event for the final session. So for today's session, we are glad to have the experts in gut microbiota all the way from Japan, which will share their experience, their thoughts in the title for the next generation health and medical care, the new approach by frontier science and technology from Japan. This session will be moderated by Dr. Tenagi. With this, I would like to invite Dr. Tenagi to moderate the session. Please, thank you.
Okay, good afternoon, everyone. Thank you very much for Lebanese Malaysia for organizing this event. So we are now entering the final session, which is mainly done online. So if you can connect online, please connect online. Yeah, and here in the third session, the last session from this next Bio-Teachat, and this is actually also supported by JICA or Japan International Cooperation Agency, and my name is Tenagi from MetaGen Global Business Development. And there will be 3 speakers from MetaGen, actually all from Japan, and 2 of them will be connected online. And they are the board members. We will talk about the gut microbiota for the next generation of health and medical care, and the new approach by the Frontier Science and Technology from MetaGen Japan. So for the chair will be Dr. Fukuda, MetaGen CEO. So now time, please, Dr. Fukuda, we will give it to you.
Okay, thanks. You can you hear me? Okay. So firstly, thank you very much for joining our online seminar. So yeah, I'm Shinji Fukuda, founder and CEO of MetaGen, and professor at the University of Japan, and also visiting professor of the University of Economic Malaysia in JIIT. So today we actually have the seminar, the gut microbiota for the next generation health and medical care. So actually, I like to going to talk about the gut environment and its relationship to overall health. Why is it important in Malaysia? So yeah, before starting my scientific curve, I would like to start this word, brown gem. So do you know the brown gem? Yeah, I know you don't know the brown gem, but we call this one brown gem. Yeah, good. So I try to create a health and longevity society based on this brown gem. So the reason why I believe that we can create a health and longevity society based on brown gem, that brown gem contain gut microbiota. Alright, so I'd like to introduce the orientation movement using this computer graphic. So camera swim the intestinal movement and goes to the intestinal wall, and then you can see here a lot of villi are there. So if you see the surface of the villi using electron microscopy, huge number of microbes colonize the surface of the villi. So as you may know, 1,000 species of microbes are there, and also around 40 trillion bacterial cells are colonized in our gut. As you may know, the human body cells around estimated that is 30 trillion cells, indicating that the gut microbes, the number of gut microbes higher than human body cells. So actually, in the crypt cell of the fly, this crypt cell produce the anti-micropeptide and also immunoglobulin A. So that's why this host molecule can balance the gut microbiome. So again, that camera swim into the movement and reach to the colon, and you can see over there, huge number of microbes still colonize in the intestinal lumen like a galaxy. So in the clone, the length of the villi is shorter than small intestine. So actually, we make this computer graphic for the TV programs. That's why the bacteria hit camera and also E. coli swim the intestinal lumen using their flagella. But most of gut microbiota don't have fertility because they can get their energy without any difficulty. So what is their nutrients? That is dietary fiber and undigested protein, so like this. So gut microbiota metabolize them and they get energy, and also they produce the many kinds of metabolites, which is the very low molecular compounds. So that's why this microbiota that metabolites partially absorbed from the intestine and run the whole body through the bloodstream. So that's why gut microbiota that metabolites very important not only intestinal homeostasis but also whole body homeostasis. So next, I'd like to show you the features of human gut microbiota. So this is the result. Yeah, this is the gut microbiota composition for the 2 years of 7 healthy Japanese volunteers, including male and female. So you can see here ID 1 from 1 to the 7, and this you can see that this bar graph means that from top and the bottom is the 2 years. The one bar meaning that one microbiome profile at a time point. And the different color means different bacterial genus here. And you can see here the gut microbiome profile is relatively stable within individual, but very different individually shown here. For example, in the ID 5, 6, 7, they have a high abundance of this brown color bacteria like the bacteria, but ID number 1, 2, 3, 4, there are green color bacteria high abundance actually. Why that gut microbiome very different individual? It has been reported that long-term dietary habit is tightly linked to this bacterial type. So if you eat a high-fat, high-protein diet, the bacteria is abundant. But if you eat a high-carbohydrate diet, including a dietary fiber, the bacteria are abundant. So yeah, that's why our long-term dietary habit is really important to decide your gut microbiome type. But my next question is, what does the gut microbiome type bring about? So yeah, 5 years ago, very shocking paper reported. Maybe you know that immune checkpoint inhibitor that is usually as the blockbuster for the cancer treatment. So these 3 different groups reported at the same time, back to the journal Science. They reported that the responder of this immune checkpoint inhibitor is, based on the gut microbiota. The feature of the responder is that the responder has a high alpha diversity and the high abundance of the Akkermansia and the bifidobacteria. So meaning that your gut microbiome type is tightly linked to the effectiveness of immune checkpoint inhibitor. So then, why is gut microbiota important in Malaysia? So the first reason is obesity. So, and the Deputy Health Minister in Malaysia said 1 of 2 adults in Malaysia is overweight. So this article is from the New Straits Times, which is the Malaysian newspaper company. Maybe the obesity is tightly linked to the imbalance of gut microbiota, which already reported in 2006. So that's why if you want to control your body weight, it's very important to control your gut microbiome. And the second reason is colorectal cancer. So this is the 5-year prevalence rates of the colorectal cancer. So yeah, in the dark green color means the high proportion of the high proportion of the colorectal cancer. You can see here in the China, Korea, and Japan, and Turkey, and Singapore, and Malaysia. These countries had higher 5-year prevalence rates of the colorectal cancer than the other Asian countries, indicating that, yeah, we have to take care of this colorectal cancer. And also, it has been reported that colorectal cancer is related to the gut microbiome and dysbiosis. So the Takuji, he's the CDO, the Metagen. He will provide us some new findings regarding the gut microbiota and colorectal cancer, and also he provide us some how to utilize this gut microbiome dataset to prevent and to diagnose the colorectal cancer. So next is my next question is how can we use gut microbiota in medical treatment? So actually last November, big news came because the FDA in the US approved the fecal microbiota suspension as medicine. The target of this the medicine is recurrence of Clostridioides difficile infection, recurrent CDI. So this recurrent CDI is a big problem in US, Europe, and also Asia, including in Malaysia. So that's why this news is very important for the Malaysian people. But in Japan, the recurrent CDI is a little bit rare disease, but ulcerative colitis, the one of the IBD, is a very big problem in Japan. Yeah, I know that in Malaysia, you see ulcerative colitis to be a rare disease, but in Japan, it's a very big problem. So you can see here that number of you see patient. The number of patients is going up in the recent. So to cure this ulcerative colitis, yeah, now fecal microbiota transplantation is utilized to cure this disorder. So the fecal microbiota transplantation protocol is very simple. So healthy donor to recruit it and then collect fecal sample and mix the homogenate and buffer. And this brown juice was filtered, and then this brown juice was inoculated by the colonoscopy to the patient intestine. Actually, in this point, Dai from the Chief Health Officer Metagen, he will provide, he will explain the detail of FMT, and also he will give us some new insight into this FMT and UC. So this is the last slide. I would like to show you our brown ocean strategy. So this is the world map, and the human being eat food to live. But in that case, all of the human beings produce this brown gem in all over the world, but all of this brown gem are discarded. But the brown gem contain valuable information and also beneficial microbes. That's why we decided to collect this fecal sample from all over the world, and then we make some valuable information and valuable product and provide to all over the world. That's why we try to create the health promotion and longevity society based on our cutting edge student nurses. So, I would like to stop my talk here, and I would like to move on to the next speaker. So, next speaker. All right. So, next speaker is Fuji Yamada, the CTO Metagen. So, Fuji, can you hear me?
Hi.
All right. So, please start your talk when you're ready.
Okay. So yes, just wait a minute. Can I share my slide?
Yeah.
Yeah, can you hear my voice as well?
Yeah, no problem.
Okay. Okay. So thank you very much to give me this kind of opportunity, and I'm very happy to talk and introduce my work and around the gut microbiota and it's associated for the cancer things. And my name is Takuji Yamada, and I'm working as a CTO in the Metagen, as also working as an associate professor in Tokyo Institute of Technologies. And today I would like to introduce my recent work and associated with cancer, in particular for the colorectal cancers and how to utilize the information to treat the cancer. And then I hope my network connection is properly working during my talk. So if my network is will be down, please say some funny stuff by Fuda-san, please. And then okay, so yeah, this is our outline of this talk, and then as I will introduce a little slightly the summary informations of the human gut microbiota just before the clinical information as well. So gut microbiota, as you know, this is one of the big issues for in this decade, and then gut microbiota, the dysbiosis of the gut microbiota will induce some higher risk of the certain diseases, in particular for the colorectal cancer or inflammatory bowel disease or liver cancer or those kind of things. And recently there are tons of the research topics or diseases are reported as an association together with the human gut microbiota. And then, but to measure or the gut microbiota or to see or to to analyze the microbiota, there are several measurement or technologies in the scientific technologies. For example, the metagenomics or metabolomics or those kind of things. In particular, in my work, I will focus on the metagenomics. So I will summarize what is the metagenomics just before to move into the detailed analysis. The definition of metagenomics is that the DNA fractions from the environmental sample, for example, soil or oceans, in our cases, that is for the fecal samples, and then we extracted the DNA from fecal samples and then do the sequencing, and then we get some data, and then we do the analysis together using the sequence data. Then we can get that kind of information. So using the metagenomic data, we can get the phylogenetic compositions of the human gut microbiota, meaning that what kind of bacteria are living there and how much fraction of the bacteria of the human gut microbiota is this kind of bacteria. That kind of things you can get it. And then using these technologies, the number of publications associated around the gut microbiota is going up in this 15 years. I studied the gut microbiota studies or the work around in the beginning of the 2000s, but from that time, the number of publications is going up. And one reason is that because of the metagenomics, that it's easier to use it, and you can see what kind of bacteria are living there in the gut microbiota. For example, we can also think that make a type of the microbiota. For something like a blood type, you can categorize you are this kind of bacterial gut microbiome type, the bacterial type, bacteroides type, or Prevotera type, or Rhinococcus type, that kind of things. And then, but using the established data analysis pipeline in the recent years, not only for the bacteria, we can also get some get functional information from the gut microbiota. What kind of enzymes are overrepresented in this disease, or you can also get the phage information, not only the bacteria. What kind of phage virus information you can also get it, and then you can also reconstruct the genome information. For example, this kind of bacterial genome structures you can also get from the metagenomic data. That is a big issue in these 5 years. Then again, so you can also see this kind of the high explosion of this number of the publications. So there's two reasons because of this kind of of this curve. One is the metagenomics analysis, and the other is the association to the disease for the gut microbiota. So this is the list of the disease which have already reported the association to the disease and the gut microbiota. This is just part. But in the recent studies, more than 50 number of the diseases are reported as a kind of association together with the gut microbiota, and it's huge. And then, in particular, I am focusing on we are focusing on the analysis for the colorectal cancer. So, and here I will move into the application of AI-based microbiome research. As one is a clinical study for the colorectal cancer. So this is I have to say that this is the number of the increasing the number of the incidence of the colorectal cancer in Japan. So in both of the colon cancer and the rectal cancer, the number of patients is going up, and this is 10 times more than before in 30 years ago. And then our genetic, we don't have we don't evolve in this 30 years, but the number of patients is going up. So we are not sure why this kind of happens, but we have to think about. And then the cancer is originally called as a genetic disease because something like the APC or RAS or the somatic mutations are stacked onto the somatic cells, and then 3 shots of the mutations will make the normal epithelium cell to the carcinoma cancer. And that's why these kind of the reasons that cancer is called a genetic disease. However, in 2018, and the epidemiology tell us the impact of the diet, the risk of the colorectal cancer. So meaning that this is in Japanese case, but even in both of the male or the female, the westernized diet will increase the risk of the colorectal cancer. And then the healthy diet or traditional Japanese diet, compared with the healthy diet, traditional diet, the westernized diet will have a higher risk to the people cause cancer. So, but question is, something should be happening in the gut, but we are not sure what kind of things happens in the human gut microbiome in the gut as a factor of the causation of progression of the colorectal cancer. And there are several papers have been already reported around the mouse model. The mouse models exposed to the particular diet or microbiota to show cancer as a factor of the cancer. But the point is that something like that, we feed something to the mouse, and then we can also check whether the foods progress the cancer or they happen the cancer, all those kind of things. But remember that we are the human, and then the mouse is mouse, and then gut microbiota patterns is a bit different. So there are several difficulties just to compare the directly from the mouse and the human. So we are prepare the kind of the multi-dimensional data around the gut environment. So not only for the metagenomics data, but also the metabolome data or clinical data or lifestyle data, dietary information. We put everything on as one of the code data, including the cancer study. And totally we have it's just previously that is close to the 4,000 subjects we have already recruited, and the more than 1,000 of the metagenomic deep sequencing data, and more than 1,000 of the metabolome data we have already collected, and then we can check what kind of microbiota will cause the cancer, or what is the result of the cancer as a microbiome patterns. And then this is the kind of collaboration of National Cancer Center in Japan. That's why 2/3 of this all the property will be the cancer patients, but 1/3 of them is healthy control, and the 1,000 of the healthy control. Then we are doing the kind of comparison, comparative analysis of gut microbiota. And now this is the study design. And then firstly, we recruited around 600 patients containing the healthy to the stage 3 and 4. And then this number, this is the kind of according to the stages, we recruited the number of the patients. And then in particularly, this intermediate patient, the category is the most important things, because the cancer patient, the cancer progression time during from the healthy to the stage 3 and 4, with more than 10 years or 20 years we should spend for the time. That's why in this kind of middle parts that it's very difficult to get samples. But we recruited all the patients. And then this is the kind of the overview of the patients' gut microbiota patterns. And then for each, the column represents the patients, and then each record represents the bacteria or metabolite things. But this is a bit difficult to understand, but we can move into this the two-dimensional plot. So one dot, it represents one patient. And then if the patients close to each other on this plot, their microbiome pattern is very close. And then the color of the plot is representing the category, the healthy or stage 3 and 4, those kind of things. And in the beginning, we thought the pattern, the microbiome pattern should be similar according to the stage-specific pattern, as a stage-specific pattern. But in reality, as the microbiome patterns, we don't see the kind of cancer microbiome pattern. That is also metabolite as well. We don't see any particular specific patterns for the cancer microbiome pattern. However, we found this kind of the bacterial overrepresentations according to the cancer progression. So this is a stepwisely overrepresented bacteria. That is a Fusobacterium nucleatum. So if you, so this is a big thing. However, this Fusobacterium nucleatum is not our original discovery, because this is this bacteria have been already reported in 2030. The Fusobacterium nucleatum infection is prevalent in human colorectal carcinoma. So this is a one example. But even though this is the Fusobacterium nucleatum overrepresentation, we can find it even in a Japanese cohort. So this is a clear case. And then you can also see this intermediate pattern. So this is a stepwisely overrepresented, even in the early cancer stage. So if you can 5-year survival rate of the cancer in the early stage of the cancer, that is almost 100%. So if you can find the early stage of the cancer in using these microbiome patterns, you can survive, and you can help the people to survive more than 5 years. So that is a big issue. And then so this is one of the bacterial species which have overrepresented according to the cancer stage. However, we can also check. In addition, we also check the another bacteria which have a similar patterns. What kind of unique patterns of those together with most of the bacteria we can check. And then this is the 4 bacterial species we can see: Fusobacterium nucleatum, and the Saurobacterium mue, the Peptostreptococcus stomatis, and Parvinomonas micro. So these 4 bacterial species have a similar stepwisely overrepresentation pattern according to the cancer. And this four bacteria, this pattern is not only for Japanese cohort, but also for the Japanese and then Japanese, Italian, and the Chinese and the German cohort. All of this worldwide cohort study have a totally similar pattern, overrepresentation pattern for these 4 bacteria. So I strongly recommend, if you can see this bacteria, if you have a time to check your gut microbiota, and then you can see this 4 bacteria, I strongly recommend to go to the colonoscopy. And whether you don't have to check whether you have the tumor or the cancer in your gut. And at the end, these 2 bacteria are much more important things, because Atobobium pallidum or Actomyces odontolithecus, the 2 bacteria as overrepresented only in the early stage of the cancer, meaning that so these bacteria might be the kind of the causation factor of the cancer, not on the accelerate the progression. This is the causation. We are not sure yet, but we will we are trying to feed this bacteria to the mouse model, and then whether this bacteria cause the cancer or not. And this one, that is a butyrate producing bacteria. Some of the bacteria are underrepresented in the cancer. I cannot say this bacteria will cause the cancer, but as the observations, these bacteria are underrepresented in the cancer. So this, clear pattern we have observed to check the cancer progression to see the metagenomic data from the cancer patients. And then not only for the bacterial species, we can also check the metabolome data as well. So there are tons of marker potential metabolite in particular for the amino acid or DC or bile acids, that metabolite also might be the potential biomarker. We are not sure this is the causation or not, but as a biomarker, we can use this metabolite as well. And then I am a bioinformatics researcher, so we are also constructing a machine learning model to predict the risk of cancer from the metagenomic data. And then this is still under construction, but we can see using the microbiome data, we can also infer or predict the cancer risk or the no risk, the similarity to the cancer patient from the gut microbiome data using the machine learning model. And you see that is close to the accuracy. That is not so bad. And then still we are not in the case of the clinical we cannot use this as a diagnostic tool, but in the near future probably we will come to see we will see the kind of the diagnostic tool based on the microbiome signature. And then this is all normal things. And then we can also do the kind of the local explanation, show the different pattern of bacteria impact on each CLC subject, meaning that the previous machine learning model can only say that the risk or similarity to the cancer progression model. But in this new local explanation AI can explain the reasons why you have a risk of the cancer because of the Fusobacterium or because of this Streptococcus tomatis, and that is totally defined according to the patients. So this kind of the new machine learning model we can also publish in this is an impress, so it will be sooner or later will come. So what is and then so we performed the large cohort study and the Bloom defined taxon along with cancer progression elevation of the fecal amino acid predominantly in CLCs and the potential of the microbiome in clinical applications. We are not still in a clinical scene, but we have a strong potential those kind of things. And then these papers have already published and associated with this research from our group. Then cancer is a genetic disease, I said, but cancer is a genetic and a microbial disease. We are sure that we can say that. To progression or causation, probably the cancer, the microbiome will associated with those, but we're not sure why or the kind of things. So the mechanism will be discovered sooner or later in this decade, next decade. And in the last time, I also explained as a business parts of the gut as a service of the gut assessment service from the Metagen. And then we are the company, and we also provided this kind of the gut environment assessment service for the B2B2C model. And then that is why we can do it, because as I said, if you have a kind of the Fusobacterium or those kind of things, we know the kind of risk of the cancer. And then, this is not only for the risk of the cancer, but we can try to, provide our gut microbiota checking service. And then the patient, the consumer can send their fecal samples using our kit, and then send back to our office. We can check what kind of bacterial species and what kind of metabolite you can see in your gut. So this is kind of the report examples from the gut environment assessment report from our service. And then once you send your fecal samples to us, and then we will send back to the microbiota profile and metabolite profile and the disease similarity, as I said before, including the cancer. So, and here's the example, and with the population number. So the first thing you can see the gut microbiota profile, and then compare with the another the average issues. What kind of bacteria are the more than the average. And then you can also see the metabolite profile there and the bacterial abundance in your gut here. That kind of things you can get it. And then here is the disease similarity. This is not diagnostic, as I said before. So, but we can using this background of the system, using the AI system, we can make a scoring. We can make a score of the probability for each the cancer or common disease, obesity, and then those kind of things. And then yes, so far we can provide this kind of services, and then if you have an interesting in this, you can also contact the people in the working they're located around in the local place here, and then this is a typical gut microbiota indicator similarity to certain disease, and then this is just one example. Once we have a high similarity to this is one case we can show you. That is for the Mr. A. So once we make a high score of the colorectal cancer for them, for this guy, and then he went to the doctor to the colonoscopy, and then we found the kind of big tumor in the gut. So this is just one case, but this happens, so we can think about the power or potential of this service as well. Yes, and then the future aspect. So as I said before, not only for the cancer, but also the another disease have already reported, and then we can also implement this kind of the disease risk things onto the service. But this is not the diagnostic tool still yet. But probably this service will go into the diagnostic tool or not. We are not sure yet. But we have to think about how to use diagnostic the microbiota as a consumer service. So, and that's it for me. And I am very happy to get any questions, including the bioinformatics analysis way or cancer things as well. Thank you very much.
Guji, thank you very much for a nice talk. So yeah, you can clearly identify the gut micro feature in the difference in the stage of colorectal cancer in the human cohort. So it's time to open for discussion. So do you have any question or comment from the audience? So or online, if you have the question using please use the reaction or chat box. So do you have any question? All right. Okay. I will take the first question, Takuji. So in your data, Fusobacterium is one of the biomarker to detect the cancer. But in my feeling, that is the Japanese cohort. Do you think it can apply to the Malaysian people?
I think so, because this Fusobacterium nucleatum or Sarawakbacterium aureus, those kind of things have been already reported not only for Japanese but also Chinese and Italian and Germany, and yes. So meaning that probably these 4 bacteria could be the universal biomarker in the world as for the cancer biomarker. So probably we can use. Of course, we have to check it in the cohort, in the original cohort. However, in my opinion, probably Fusobacterium will overrepresented in a cancer patient in any other countries.
All right, thank you. So how about the other early stage of colorectal cancer, and a biomarker of the bacteria? Fusobacterium is one of the major marker, but how about the other early stage of colorectal cancer biomarker?
Thank you very much. So the Parabinomas micro, those kind of 4 bacteria, that would be the potential biomarker that will work. But for the Atopium pallidum, unfortunately, this bacteria is reported only in Japan or as a cancer marker. Of course, the Atopium pallidum have been already reported from the another country, but not for the biomarker for the cancer. So that is not, I cannot say this. We can use this as an early stage biomarker. Yeah.
You mean you need some data set from the Malaysian
yes.
patients?
I think so. Yeah.
Going to some collaboration with the Malaysian.
Yeah. In particular for the early stage of the cancer.
All right, thank you. So time is coming. I'd like to move on to the next speaker. Takuji, thank you very much.
Bye.
All right, so the next speaker is the Dr. Dai Ishikawa, the Chief Health Officer of the Metagen. So Dai, please start your talk when you are ready.
Thank you. Thank you for introducing me. Can you see?
Yeah, okay.
Okay. Okay, I'm Dai Ishikawa, Chief Medical Officer at Metagen Therapeutics, and Associate Professor in the Department of Gastroenterology and Junten University. Yeah. Just a moment. This picture is a very beautiful picture. Junten University is located near the Loyal Park. In the spring, we can see a beautiful cherry blossom along the Loyal Park. Okay. Apa kabar? Nama saya Dai Ishikawa. As Fukuda explained earlier, an FMT is advanced microbiota therapy that restores the gut microbiota and collects the dysbiosis of microbiota by providing full spectrum microorganisms of healthy individuals to the patient, so that the patient can obtain a complete functional ecosystem. It is a simple way. We just transfer water and ubically filter the bacterial suspensions into the patient's colon by colonoscopy. That's it. FMT, it has been proven to be effective for treating refractory and recurrent Clostridioides difficile infection in 2013. A CDI is caused by long-term antibiotics. And CDI treatment guidelines published in the US and Europe, it is stated that FMT is a strongly recommended regimen for CDI with multiple recurrences, with an outstanding effective rate of over 90%. And so Open Biome, non-profit organization in the United States, is committed to the providing an internationally standardized public stool bank for microbial treatment of various diseases. They can, in United States, and the doctors can buy their fecal suspension from the Open Biome. Maybe your price $1,700 and over $2,000 like this. FMT can treat CDI. However, the use of FMT for the treatment of MPD including ulcerative colitis, is still progressing toward clinical application. IBD, inflammatory bowel disease, is an intestinal disease characterized by chronic inflammation of the intestinal mucosa that is prone to the relapse. Common clinical types mainly include ulcerative colitis and Crohn's disease. Usually is a long-term condition that results in the inflammation and ulcer of the colon and like that. You can see the deep ulcer in here and bleeding, and mild is here, the moderate and severe. The primary symptoms of active disease are abdominal pain, severe pain, and diarrhea mixed with blood, weight loss, sometimes fever, and anemia may also occur. The cause of use is unknown, still unknown. Sorry. Okay. And in Japan, the patient with ulcerative colitis, the number of the patient with colitis has increased. There are, in the last 10 years, almost double. There are over 200,000 patients with IBD in Japan. It mainly affects young people in their 20s and 30s. Their medical burden is increasing and it has become a social problem in our country. And you see, actually, 4 RCTs randomized control studies have been reported. 2015, 2 RCTs were reported. The results are controversial. The 2017, 2014, using and proven the efficacy using multi-donor intensive FMT 41 times. But this approach could be time consuming and complicated. 41 times FMT is so many. And so we propose a new method called AFMT, antibiotic FMT, which is a combination of subtracting and adding by using antibiotics and FMT. So I would like to explain the protocol to you. A patient received AFM therapy. AFM therapy is amoxicillin, fosfomycin, and metronidazole, 3 kinds of antibiotics. By fresh FMT using colonoscopy, AFM was administered to the patient with UC for 2 weeks and up to 2 days before FMT. This figures is the composition of a microbiota and donors. This is red indicated Bacteroidetes phylum. The phylum green indicate phylum Firmicutes, and yellow is Proteobacteria. There's no significant difference between the donors and the UC patient and the composition of their microbiota. However, antibiotics change the microbiota dramatically. After 2 weeks AFM antibiotic therapy, Bacteroidetes was gone, almost gone. And after FMT, means Bacteroidetes recovered. If we look at the end is more detail, we can see that the Bacteroidetes is recovered in the patient who has been treated with AFMT, and not in the patient who had no therapeutic effect. Responder is recovered. On the other hand, no responder, not recovered Bacteroidetes. So graph on the right shows the degree of the recovery of Bacteroidetes between the antibiotics alone group and AFMT group. It was found that Bacteroidetes were significantly recovered in the AFMT group than in the AFM antibiotics only group. And the patient who had a therapeutic effect responder in the AFMT group had a significant recovery of Bacteroidetes. So we focus on the Bacteroidetes. Major, so we predicted Bacteroidetes species has a potential to cure inflammation. To find beneficial Bacteroidetes species, This heat map shows bacteroidetes species and patient before healthy donor and before patient, after patient, that they are donor. We found that the patient with UC had dysbiosis in species of bacteroides compared to healthy donor. This donor, number 14 donor has many bacteroides species like this, over 14 species. On the other hand, the ulcerative colitis patient has only 5 species. So this is after FMT. After FMT, this patient has these species from donor, no species, but after FMT, like this. Then, in addition, we reported that the proportion of bacteroides species in UC patients decreased compared to healthy subjects, like this. Healthy has over 1% composition in Erysipetes pteridines. On the other hand, UC patient has very small number of the composition, 0.037. And that's the proportion of their bacteroides species decreased further with severe illness. In other words, we were able to prove that the bacteroides species can become a biomarker of UC. Let me show one case, 30 years old man. On the far left shows the microbiome composition of donors, microbiome composition, and the patient before FMT. And after FMT, 2 weeks after FMT, like this, almost same, very similar to the donor composition, 4 weeks, 8 weeks, like this. This colon ulcer was cured, and 2 years. Over the next 2 years, symptoms stabilized and microbiota continued to undergo similar changes to donor. The endoscopic findings show a remission, as you can see. To search of therapeutic bacterial species to UC, we focus on the cases like this, how significant response to the AFMT, isolated bacterial species from effective donor stool, and evaluate their function in vitro and in vivo. Step 1, like this, we focused on the very champion case and isolated bacterial species from fecal material. Step 2. And step 3, evaluation of the immunological function of in vitro. And step 4, in vivo evaluation. We took the 25 bacteroides species from donor, good donor. And we evaluate the induction by temporal induction by dendritic cell. So we found out of the 4 species induct the temporal induction, including AP bacteria, Erysipetes pteridines AP. And next step, were transferred transplantation of isolated AP into their animal mice, and the entry induced by DSS or oxazolone. The AP bacteria can suppress their body weight loss compared to the control. The aim to base the reverse translation approach for the promising bacterial species was shown to be an effective method for microbiome drug development. Last year, we obtained a big grant from the Ministry of Economy, Trade and Industry, and we would like to strongly promote microbiome drug discovery in Japan. FMT is also great, but I think it is important to make it useful in drug discovery in the next step. Right. Final. How about the efficacy of AFMT? Who is a best donor? This is a flow chart and this study includes 37 used patients in AFM. AFM means antibiotics only, and 55 used patients in the AFM. At 4 weeks after treatment, almost 70% patients showed clinical response in the AFMT. Furthermore, 90 UC patient achieved clinical remission, the perfectly response. This rate is higher than I expected. This rate is almost the same to biologics. As a result, the curriculum non-relapse rate is maintained, and the FMT can maintain the symptom in the patient. Then we examine the factors related to donor in AFMT. FMT between brother and sister has significantly higher cumulative non-relapse rate than transplantation between the parent and the child. It means brother and sister siblings donor is so effective to the patient, use the patient. Matching is the best between the brother and the sisters compared to their child and parents. Everyone, take good care of your brothers. And over 11 years difference between their donor and their patient age at a significantly lower, less than the 10 years group. But age difference between the patient donor is also important factor to keep a remission. So brother and their similar age is good matching. Finally, I would like to touch on the cancer treatment. It has been reported since 2018 that the microbiome affects the therapeutic effect of anti-PD-1 ICI, which is one of the anti-cancer drug. ICI is effective to cure cancer. However, its efficacy is about only 25%, maybe. It has been reported that melanoma skin cancer patients who did not respond to ICI were significantly effective, over 30 to 40%, when FMT using the donor stool of the responder patient was performed. I think this is a wonderful precedent for the application of FMT to the cancer patient. With the aim of standardizing and stabilizing the preparation of the microbiome solution method in our hospital, we have developed a simple microbiome solution manufacturing process using a single-use container and the joint research with Metagen Therapeutics. Since the process from the mixing homogenize of stool and solution can be easily carried out of the anomically in the closed system like this. Result of leakage and the system is embraced to stabilize high cold solution. In addition, it has made it is possible to further shrink it. We want to deliver the FMT's treatment and microbiome drug discovery to many patients with the power of microbiome science. Thank you for your attention.
Thank you, Dai. Nice talk, and you clearly show that the mechanism of how the FMT can occur that losing patient and the abundance of the bacterial duress is negatively correlated with the score of the UC patient. So yeah, do you have any question? Oh yeah, so we have the question from the online, Dr. Lee Yan. So the first question is the donor selection is important in FMT. A super donor may have better outcome. Thus, who are the associates of your donor?
Yeah, good question. Thank you for a good question. Yeah, I'm still looking for golden donor to cure ulcerative colitis just now. But I think it is hard to find golden donor for every UC patient or patient. I think matching is more important. Patient, between patient and donors. Maybe other donor to the patient. Maybe sort of the brother is similar to the patient. So if we find the matching algorithm and the microbiota between the patient and the donors, we can find and make a more effective treatment FMT for the patient. Hi.
So
聞こえますよ。
the connect.
はいはい。
So
聞こえませんか？
Yeah, but it's not so smooth. So please stop your movie.
A movie.
Video. Yeah, video.
Okay.
Maybe the connection.
Okay.
Improve maybe.
Okay.
Alright. So the second.
Can you see? Can you hear me? Can you hear me?
Yeah, but yeah. Sorry, time is coming. So can you answer the
good?
Yeah, in the chat.
Can you hear me?
No problem. Yeah, but yeah, sorry, time is coming. So yeah, so please ask the question from the online. I mean, Dr. Lee, and yeah, he has one more question. But yeah, sorry, time is coming. So please ask the chat box. So yeah, thank you very much. Bye. All right, so yeah, I'd like to summarize this. Okay, I would like to summarize my this session. So yeah, I have firstly I am a first speaker, and I have introduced the feature of the human gut microbiome, and gut microbiota type. It depends on the long-term dietary habit. And the second speaker, Takuji, gave us the insight into the gut microbiome and colic cancer. And Dai, the final speaker, Dai, has provided the possibility and candidate the mechanism of FMT for UC and application of ICI. So recently, many academic papers have been reported in the gut microbiome research field over the past decade. But the market utilizing the gut microbiota is still ongoing. And in Malaysia, we hope to utilize the gut microbiota to prevent the treatment of the diseases such as obesity and colorectal cancer, which have become a problem in the recent years. So finally, thank you very much for joining us today. And please give a big hand to the speakers, Takuji and Dai. Okay, so back to the Agi.
Okay, thank you very much, Dr. Fukuda and Dr. Takuki Yamada and Dr. Kawadai. So thank you for the participation of maybe offline and online participants. And thank you very much for Livanese Malaysia for organizing this event, also with support from JICA Japan. We hope you all can get new insight from us today, and might consider for a future collaboration maybe with MetaGen. So for the final request, we would like you, the participants, to answer the questionnaire that we will share later after this. So maybe the Livanese Malaysian member can share it with them. So once again, thank you very much, everyone. So I will return it back to Livanese Malaysia.
Hello, good evening, ladies and gentlemen. Yeah, thank you, Tenagi-san, for the moderation. Also, thank you to all panelists for the great discussion. So really appreciate it. Now we have come to the end of this event. So without further ado, perhaps we'd like to invite our director, Livanese director, Mr. Noor Ahmad Zaim, to deliver the closing remark, also to share his thought on the event. Please welcome Cik Noor Ahmad Zaim.
First of all, I would like to extend my gratitude to all our partners, MetaGen, VitaGen, and also UKM for having us agree to become a partner for our event, Bio-Teachat for today's. So I think a lot of knowledge that we receive from this Bio-Teachat, especially related to the gut health symposium regarding the gut health and how we can, from the gut health, we can improve our daily health and also daily activity in terms of that, improve our health lifestyle. So hopefully from this Bio-Teachat, it can become something that continue that we will do, not only related to gut health, but we would like to continue with it. And this will be the bridge for us to create a new collaboration between the researcher, companies, Malaysia, and also Japan, also other countries. And we continue to further our research and also collaboration and bringing the technology to our society. So that is our main goal for this Bio-Teachat. And lastly, I think the most important is from this kind of activity, we hope we can bring advancing science and technology for global happiness. I think that's all from me. So thank you very much.
Thank you so much, Mr. Ahmad Zaim, for the closing remarks. Ladies and gentlemen, now we already come to the end of our event. So on behalf of Livanese, they would like to present a token of appreciation to our partners, MetaGen. For this, we would like to invite the founder and CEO of MetaGen, Dr. Shinji Fukada, and also the director of Livanese Malaysia, Mr. Ahmad Zaim, to come to the front stage for the token of appreciation presentation. Please welcome. Thank you so much to Dr. Shinji Fukada and also Mr. Noor Ahmad Zaim. With that, already end our session. So on behalf of Livanese first, we'd like to thank you to all our partners, our strategic partners, UKM, Faculty of Medicine, our partners, corporate partners, MetaGen, and also VitaGen, throughout all this tremendous support, which without the support, we could not organize this event. For that, we would like to thank you to all audience for staying with us to go learn together about the gut microbiota. So hopefully this could benefit us all. So with that, my name is Arif. I would like to thank you and see you maybe during in next event. Thank you. Okay. Feedback, ambil gambar. Okay. Dear ladies and gentlemen, we really appreciate if you could provide us some feedback. This is important for us to improve the event for the future. And please scan this QR code as been shown in this. Thank you.